Hi, my name is Eric. I am a technical sound designer. This video is a demo to showcase my portfolio project where I integrated Wise with UE5 sample cam Lyra. The purpose of this project was to not only work an engine but also to make a full game with the AI enemies and players as well. This video will go through the full process of the project from start to finish. Hope you enjoy. So, starting out on the project, the first thing I did was find out what sounds were in the game, what sounds I can add, and where the existing audio hooks were. Using what I gathered, I put all the information in the spreadsheet as shown on screen. This spreadsheet also tracked information like variations, looping, implementation, and current progress as well. My next step, of course, was creating everything. Using logic, I started to put together some sounds that I already had to begin creating the game assets. These were organized in different project alternatives based off what type of sound there are. But while creating the weapon sounds, I began to realize that I needed to export them modularly for the implementation to work for the full project. This was mainly because the same sounds had to work not only for the player character but for the AI characters as well. I separated these into close shots, far shots, tails, and mechanical layers of each gun with different amount of variations per elements. After creating all these assets and variations, I started to work on the music side. So, before I started to work on the music, I wanted to brainstorm ideas for the implementation. In the original game, the music would change based on how many control points you've captured at the time. I wanted to make the music also respond to the capture points, but I wanted to write it in my own style and implement it in my own way. So what I decided to do it was 3 vertical layers broken up into 2 bars each, and then 8 times, making it a 16 bar phrase. Now the first 7 times it would repeat, it would choose a completely random file, but the last time it would choose the same file, which was a 5 chord. Again, these are broken up as vertical layers, so they were added upon based off the player character's team's capture points. And I didn't just fade them in as well, I decided to use custom transitions, either in the 1 or the 5 chord, depending on where in the music the player is. Now, on top of layer 3, I also added a linear melody in the French horn that would just play throughout the whole entire thing, no matter which one was chosen. Okay, now let's go into the Wise project. So before I started, I wanted to make sure everything was very neat to make it a lot easier for when it came time to mix, and so that I could make macro changes to individual groupings. So all the sounds were sorted into 4 separate groups: ambience, movement, UI, and weapons, depending on their function within the game itself. Now, because of the modular nature of some of the sounds, the corresponding events needed to call multiple different sounds together in order to combine them into one event. So, for instance, you can see all of these here, and there's, of course, the bullet drop. Now, the bullet drop has a randomized delay as well as a low probability, so it doesn't happen every time, and it doesn't happen at the same time. To add even more randomization to this, I decided to use emitter with automation with 6 different pathways that the bullet can bounce upon and that you can hear happen. Weapon sounds are some of the most repeated sounds in game, and this way I didn't have to worry about ear fatigue as well. Now, one of the more unique aspects I decided to add was in the mixing itself. So I utilized the side chain here, basically dividing between high and low, and coming specifically from the player and the weapon sounds. This side chain will then take those sounds from that frequency range and put it into a game parameter. And that game parameter will basically track how loud the frequencies are coming from the player sounds and the weapon sounds specifically. Then, basically using auto ducking, more specifically the gain, I duck those frequencies from the music as well as the ambience. This way, the intensity of the music can still be maintained, but it's just carving out space in the frequency bands that are needed. The sidechain also has the gain all the way down, so it's not doubling up or anything. Okay, so moving on into the game syncs, the switches and states are pretty self-explanatory. So the music capture level, of course, tells when to switch states, uses a game parameter RTPC to kind of tell that. Otherwise, like material of the footsteps or enemy versus player team results. So here's an example of how the materials work. When it comes to states, though, there is crouch state. Crouch state is a very interesting one that I decided to add. It basically puts a low pass filter over everything when the player crouches, and it filters over time so it's not an immediate aspect. There are four separate groupings of RTPC in the project: capture, magazine, movement, and sidechain. Capture has RTPCs relating to capture points and the points overall. For instance, the pitch rises as the character spends time in the capture area, which is interacted through two of these. Okay, so next is the magazine, which raises the mechanical layer as you go farther down into the magazine. Of course, it's different for every single gun. And yeah, here's an example of the pistol. Movement is the broadest category. It has RTPCs like hero velocity and jump height that work to check how fast the character is going and will change the volume based on the speed. There's hero type, which will change the pitch of all footsteps and jumps depending on what avatar the character has, Quinn or Manny. Elevation is pretty self explanatory as it just raises the high ambience volume the higher up on the map you are and puts it to normal when you're on the normal spot of the map. So, finally, there's share sets. So, in order to blend my sounds and make them actually sound good in game, attenuation was really important. I had to utilize precise attenuation to control what the player was hearing near them as a form of balancing. This is especially prevalent for all different areas of the gunshot in order to create a seamless experience with all the other players firing. For example, control when the far shots would fade in after the close was very important. And here's an example of this. As the final part of share sets, as the project went on, I had to utilize different conversion settings for different groupings of sounds in order to further optimize the performance of the game, and especially prevent any issues leading to voice starvation and clear up the CPU usage. Okay, and finally, of course, was implementing everything into Unreal Engine. Now, the first thing I decided to do to prevent any weird diffraction errors was set the listener to the player's location, but the orientation to the camera's location. This avoided any kind of weird errors. Now, almost all of the blueprints were just added as post events or post events at location, depending on what they needed. Some were used more in the animation department, just kind of setting it up like that, but some were individual blueprints. The only ones that were actually put on the world was the weapon spawners, which use multi-event positioning and Wwise and advanced profiling to make sure that it's only one playing and prevent CPU overusage. Now, something I spent a lot of time on in this project was setting up the diffraction and occlusion using the Wwise tools that are given in Unreal Engine. Usually Unreal will count the physical material and will automatically have diffraction. With Wwise, everything had to be set up separately to work, but of course it's a very powerful thing. So I used AK spatial audio volumes and brush editing tools in order to make them fit the world around. So for instance, we have the arena here, which goes up to the ceiling, and then the hallways. Each have a different reverb as well. Every single capture area also has a different AK spatial audio volume. They're minutely different, but they are slightly different because, for instance, that capture area doesn't have a back wall. Well, that one does. It's very minute differences between the three of them. And of course, each of them, as seen in more detail, has a portal. The center is also a big place and needed a lot of reverb in order to be shown. So again, lots of portals run. I try to go for every single opening that I could find and make sure that it was covered by a portal to pass through in order to blend the reverb seamlessly and of course set up the diffraction. Now, if there wasn't something covered by the spatial audio volume, something like within the room itself, this of course got an AK geometry component added to it. Just a very simple collision AK geometry in order to count for the diffraction occlusion there. And this made everything accurate when it comes to playing the game. Speaking of, here's a full gameplay demo of the project. Okay, thank you for watching. If you enjoyed the video, please feel free to follow me on my socials.